Good morning all. Lots of post came in today, so it's another post bag. And this one's got lots of spikes sticking out of it, so it's not very brilliantly packed. I'm amazed they didn't get bent, they all seem intact. Okay, so let's open it up. So it's a triple 18650 holder. Let's see if it'll come out of this bag. Yeah, just about. And this is, well, a nice open style holder, but it's also got these PCB pins, and I figured these could be bent out so that I could put a bus bar down one side for all the negatives, probably, and measure or put a device on the positive side of each of these. And with these bent out, it should sit flat on my bench. And the idea was to put little current measuring devices on the positive side and measure the current that flows from one cell to another when you put them in parallel. So let's just try bending one of these pins out. They don't seem to be brilliantly well anchored into the slides. There's just a little barb that stops it coming out. But yeah, that seems to be all right, and that's probably enough to get a piece of wire on there, soldered on there, and that also lets it sit flat on the table. So yeah, I think that's going to be fine. Blossom. Okay, so that's done on both sides, so that was relatively easy. What I want to do now is just check whether unprotected and protected cells fit in here. I'm going to use unprotected almost certainly, but it'd be interesting to see how well it accommodates cells of different lengths. I originally bought this fishing tackle box for resistors, which actually it was very bad for, but it makes a very good 18650 storage case. So unprotected button top. Oh, it's quite a tight fit, isn't it? But yeah, that does fit. Probably need some ribbon to pull it out. Oh, maybe not. Let's try this unprotected flat top cell. Yeah, that fits no problems at all. Okay, let's try a protected cell. Now this protected cell is a good 3, possibly 4 millimeters longer than the unprotected cell, and I just don't think that's going to go in there. I'd have to really push and shove, and I'll probably end up damaging these connectors and possibly bending the battery holder out. So no, I think this is for unprotected cells only. But yeah, I think that's going to be fine for repeating my experiment on cells in parallel of different capacities, and the fact that the larger cell will both provide and also take, when charging, a larger current than the smaller capacity cell. When I've got some proper ammeters on here, we can see that in action. Good. So this is a DIY battery holder with 6 pins for 3x 18650 rechargeable lithium-ion batteries. It was only $1.33, free shipping, and this is from And Wind. Right, next up is this one, and if I get a screwdriver and put it there, the screwdriver sticks quite strongly to this one, so it would appear to be magnets. Right, let's have a look. And yes, it's neodymium magnets, but with a difference. They've got holes in them. Yes, these are neodymium magnets. They look like they're about 10 millimeters diameter, or possibly 8, 2 or 3 millimeters thick. And this was in response to my attempt. Now, I've got to be careful doing that because these are quite brittle. My attempt to solder to one of these magnets. In fact, here it is. And when I looked at this on magnetic viewing film, you could see that it had disturbed the magnetic field on the magnet. So that was a bit of a fail. And I thought, well, these are the answer. Oh, there are the holes right through. So you can put a countersunk bolt in there. I've got a feeling, can't remember if that's an M3 or an M2, but all will be revealed on the eBay listing. But what happens on the other side, of course, is that you're going to have a nut, and then the solder tag connector, or the crimp connector, will fit between the nut and the magnet. And then what I want to do is I want to be able to stack these, so the nut will become magnetized, and then the nut will sit behind a pair of these, possibly back to back. I don't know. Haven't quite worked this out yet. Again, this is for connecting to 18650s for a sort of temporary lash up. I want to use these as battery connectors. So here they are on eBay. Now this is one of these listings that's been updated and it's gone a bit weird. So there's lots of pictures of magnets here and some sponsored links. But this is the listing. Now 50 pieces it says, 10mm by 3mm. I got 20 pieces. I don't think these selection boxes show up when on the screen capture, but this has the option of 10 pieces, 20 pieces or 50 pieces. I took 20, so let me select that so that we can get the price. And there's only one option in sizes, 10mm by 3mm with a 3mm hole. That option, which you can see the picture there, comes to $2.15, free shipping, and this came from We4U365. Okay, next up is this. Let's see what's in here. Battery boxes and that. Right, these are 9-volt battery boxes terminated in, quite a reasonable length, probably about 20 centimeter length of cable with a 2.1mm inner. Oh, actually that might be a 2.5mm inner, that's quite big. And a 5.5 is it, millimeter outer. So that accommodates a PP3 style 9-volt battery. There's also a switch on there, which I thought would be quite handy for powering things like Arduinos, the little PIC demo board, and that sort of thing. And these are little packs of Neopixels on a strip, 8 pixels long. Now it looks like they're cut quite tight, so it looks like they could be put end to end. There's also a couple of screw mounting holes here. Let me get in a bit closer. Yeah, so these are little PCBs with Neopixels, or the WS2812B, soldered onto them. Quite a nice compact pitch. I think those look like they'll go end to end and you can maintain the spacing. The only problem with these holes is that if you put a screw in there, it fits in, but well, perhaps not that one, but that one, yeah, it fits in there, but it fouls on the actual components there. So there's just no clearance around that hole, so it can't really take a screw. So that's a bit odd. I seem to have gone a bit mad and bought 10 of these. I think it was 2 packs of 5. They're supplied with these little end connectors, so I suppose there's no holes for them, but you could solder them sort of flush, surface mount style on there. You've got a connector at both ends, or you can just put a little bridging link across, that way I guess, and you've got a D out on one and a D in on the other. 4 to 7 volts, that's interesting. I didn't think the Neopixels had that range of VCC, or VDD, or whatever it is. And 2 grounds, a ground on both the outer connectors. So yeah, fairly flexible I suppose in terms of connection. Just a bit of a shame about those mounting holes. So this is actually 2 pieces of the WS2812B, I suppose it should be. It says WS2811, but that's not really strictly true because that's the chip on its own without the LEDs. Yes, it's a 50/50 dimension device, RGB, LED lamp, panel, module, 5-volt, 8-bit rainbow, LED precise. Not sure why it's precise. So I bought 5 of these, 5 sets of 2. So a set of 2 is $2.39, free shipping, and these came from Alice Womano, 1983. And the 9-volt PP3 battery holder box case wire lead on-off switch, cover plus DC 2.1, it says, 2.1mm plug, is $1.02, free shipping, and those also, of course, because they're in the same envelope, are from Alice 110 1983. And yeah, these do appear to be 2.1, even though they look bigger, because I happen to know that this DC to DC converter has a 2.5 pin on it, and that definitely won't go in there. So yeah, these are 2.1mm plugs. These Neopixel strips I bought at the same time as buying a strip on a sticky back strip. This was a meter, so it was 144 of these. So actually I've ended up using this for my linear feedback shift register, but these I think are going to be quite handy for other projects. Now that I've got the pick talking to these effectively, it'd be a relatively easy thing to just solder a pick onto the back of here, run a few wires, and you'd have an intelligent LED strip with built-in microcontroller. Okay, next up is this. Let's see what's in here. Ah yes, now this is a Quick Charge 2 tester, but I think it also has Quick Charge 3 functionality. So on the back it says YZX Studio, and it's a QC Get 2.0. Now the firmware in the chip may have been upgraded since they printed these boards, because I do believe it has some Quick Charge 3 stuff. So I'm going to need to take a look at the eBay listing, because it's got the instructions on how to use this. Right, so this is a USB detector tester adapter test for QC 2.0, QC 3.0 fast charging power adapter. This one seems to be priced in pounds. I'm not sure whether I paid pounds for it. I probably did. £5.61, $6.97. So quite a lot of money for that tiny board. These must sell in very small quantities. Free shipping from Trade 021. Right, in the product detail, it says support 5 to 12 volts test and take power. Not used for charging. This item is only a USB charging tester. The new version adds the key. You can manually choose to apply voltage. You can set the default power apply voltage or loop test mode. A board versatile. Yeah, okay. Button to quickly set the desired voltage. No need to dial the code switch. Now it says red, green and blue LED indicates 5 volts, 9 volts and 12 volts. Application at a glance. There's a lot of nonsense here, but there's probably also a lot of good stuff. If I think perhaps the best thing to do is to plug it into a Quick Charge 3 port and see what we get, and then if there's any issue I'll refer back to this eBay listing. Right, so here's a power bank with the orange connector, the Quick Charge 3 compatible connector. I think it has to be this way round. So let's plug in the black YZX Studio tester. Let's just switch that on, and we're getting 5 volts. And then let's plug in this little tester unit, and it's cycling. Or perhaps it's not cycling. Oh, and of course this thing's switched off. I don't think there's any way to make this thing stay on, so I'm going to have to just keep pressing the button because it's not drawing any current. So that's 9 volts. Blue is obviously 12 volts, and red is 5 volts. Green is 9 volts, and blue is 12 volts. Okay, so those are the 3 voltages of the Quick Charge 2 standard. Now the question is how to get the Quick Charge 3 stuff. It's a shame actually this doesn't have a USB socket. Those holes might be suitable for taking one, because then I could put a load in there and this power bank would remain on. Actually, of course, it's just occurred to me that if I plug a load, like my phone for example, into the non-Quick Charge 3 compatible port, that will draw a current and that'll keep the power bank on, so I won't need to keep pressing that. Okay, let's get in a little closer on that unit. Right, yes, that's better. So now I can press this button and get the 12 volts fairly consistently, and the 5 volts with the red LED, and 9 volts with the green LED. Okay, let's see what else this thing does. Right, well I think the gist of it is that you long press this button, so let's do that. Not quite sure what that achieved. Ah, wait a minute. Yeah, something's happening. Yes, I think it's going through the incremental thing, because in Quick Charge 3 you not only have 5 volts, 9 volts and 12 volts, you can actually increment the you can tell the source to increment the voltage in steps. Now this should, I think, go over 12 volts. No, it doesn't seem to. That seems to peak out at 12 volts. Now instead if I do another long press, the red light flashed briefly, I should now be able to decrement this. No, that doesn't seem to be happening. Long press. No, that's still incrementing. Interesting. Right, I think I've got it. If I do a short press, I get a blue confirmation flash, and that means it's incrementing the voltage. It doesn't seem to want to go over 12 volts. If I do a long press, I get a red confirmation flash, and that's decrementing the voltage, but you have to keep doing these long presses to keep decrementing, and it's not going down by 100 millivolts. It's going down by more than that. Looks like more like 200 millivolts or 250 millivolts, 4728. I think it's going down by 200 millivolt decrements. Now what's interesting is in Quick Charge 3 mode, if I press and hold the button and wait for the confirmation red flash, I'm telling it to go down 200 millivolts, and it's actually now going down below 5 volts. So 4.5, I wonder how low it goes. I can't believe it could go any lower than 3.7, because these power banks generally only have a boost converter, not a buck boost. 4.3. Red flash, 4.2. This button's quite stiff. In fact, I didn't even press it that time. Red flash. I'm not sure that it can get much below about 4.2. Let's try one more time. Red flash. Yes, it seems to have bottomed out at 4.2 volts. Right, it seems this has an ability to set the default on voltage. What you have to do is press and hold the button and power it up. Wait till it goes blue and then let go. And now you're choosing which voltage it defaults to when it powers up. So if you want 5 volts, it's red. If you want 9 volts, it's green. That's what it was set on. 12 volts is blue. Red, green and blue brief flash, I think, does a cycling thing. So let's try that. And then it says you have to press and hold and wait till it goes off. Now it will boot up in whatever mode I've chosen. So I've chosen cycling. Let's see if that works. So red, green for 9 volts, blue for 12 volts, red for 5 volts. So yes, that seems to have got it into the cycling mode. Let's see what other modes there are. Right, it seems that there's 5 volts, 9 volts, 12 volts. That is red, green, blue, rapid flash. The next one is red, green, blue, not quite so rapid flash. That one is a 5-second cycle. The red, green, blue, rapid flash is a 2-second cycle. Not sure why that's gone to green. And then nothing. But I didn't save anything. Yeah, still fighting with this a bit. Right, so I think I got it into the slow flash mode, so let's try that. This should be 5 seconds per colour. Red for 5 volts. Green for 9 volts, that should hold for 5 seconds. And blue for 12 volts, and that should also hold for 5 seconds. What it doesn't seem to be able to do is go over 12 volts, but it does seem to be able to increment and decrement in these 200 millivolt steps, which is part of the Quick Charge 3 standard. Now there is a possibility, of course, that this power bank doesn't go over 12 volts. So what I'll have to do is more testing of this on other Quick Charge 3 compatible things I've got. I've got that 10 slot charger, that's also an Orkey one, which can produce up to 14 amps. That also has orange sockets. So I'll try it on various different things and see what it can do. Let's just have a tiny look at, that was a Freudian slip. Let's have a little look at what's on this board. So there's an ATtiny 24A microcontroller. To the left of that you can see a 4-pin LED, so that's an RGB LED. At the top there's a regulator, 7133, so I assume that's a 3.3 volt regulator, which can clearly take up to 12 volts on the input. Two big capacitors next to it, so one probably on its input, one on its out. And then there look like there are some resistor networks to the right of the microcontroller, 6 resistors, which presumably set the different voltage levels on D plus and D minus that indicate to the Quick Charge 3 DCP port that it should switch to either 9 volts or 12 volts, or do the incrementing and decrementing thing. So yeah, that's a relatively simple device, and at sort of $7, I mean, I think we could build something like that, probably cheaper. And so these are today's Postbag items. And it's on with the robot kit build. So what's next in the instruction list? Stuff about routing the motor wire around that thing and using that to push the wire down, and then a picture showing how the wire should be. Well, that should all be pretty straightforward. Right, so the wires go around that thing and then out the other side and out of that slot in the case, and then yeah, use that thing to tuck them down. Yeah, that works quite well. Okay, I can only do it like that. So presumably the wires come out there and keep out of the way of all the gears that are going to be sitting in this motor gearbox housing thing. Done. Yeah, I don't think that plasticky thing did a very convincing job, so I'm going to use a screwdriver to force those wires further down so they're deeper inside that little U-shaped thing. The cutout there though is not particularly deep, but yeah, that does seem to be holding it a bit better in place. Okay. Now I wonder if I can start assembling this gearbox. I mean, it looks pretty straightforward. P6 is short, P7 is long. Well, that's these two. That's the long one, I think. Oh no, that's the long one. That's the short one. Then you've got P5, which is just an axle. Yeah, there's plenty of those kicking around there. Those three there. Well, P6 is fine. That sits in there and that rotates freely. But this long one, P7, actually goes down inside there, which is clipped through that hole. But when I push that in, that's very tight. That doesn't want to move at all. So is that going to be a problem? Right, next a yellow gear has to slide down on that shaft there. Oh, and that mates with the motor. Ah, now we're getting somewhere. No, that was wrong. This yellow gear goes on that shaft, but that mates with both these two gears down here, including this one, which is tight. So that is going to be a problem. Then there's one on... Now, which one's first? Oh, I think this one's first. So that mates with that gear. Yeah, that's tight because of the gear sat in the pinched in part in there. And then you put another gear in there. So that's the total gear train. I mean, I could try the big torch. Right, big torch. Yeah, that's all jammed up. That doesn't want to turn. So, hope you enjoyed this video. A couple more up here which you might want to watch. Click my face down here if you want to subscribe to this channel. And this face here is Patreon. And I've got my new goal now, the Mediterranean Workshop. So if you want to help me achieve that goal, click here. Like or dislike below. Cheerio.